Hello and welcome. This video is designed to introduce the U.S. National Grid, also known as the USNG, and provide basic awareness on the benefits of implementing a common location language. After completing this 4-module video, you will understand the importance of the USNG and how the USNG can be applied before, during, and after disasters. Additionally, you will understand and be able to communicate coordinates and situational awareness using the USNG. This video provides general awareness training, so while completing this video will not make you a USNG expert, you will come away with a better understanding of what the USNG is and how you can use it in emergency operations. Also, please note that while the USNG is well known for its use as a navigation tool, this video will focus more on other uses. For instance, understanding how USNG point and area references can help provide full situational awareness and common operational picture will be a major focus of this video. The ability to establish a common operational picture and communicate situational awareness is a critical element of an effective operation. Communicating in common operational language keeps everyone on the same page. A common location language like the USNG provides a consistent way to describe and communicate both point and area operational references, as well as specific locations of teams and resources. With this information, decision makers have access to actionable situational awareness during planning, response, and recovery efforts. This type of interoperability is crucial for coordinating across disciplines and with mutual aid partners in complex or large-scale emergencies. The USNG provides this interoperability even in austere environments, and it is simple to teach, learn, and apply. Today, the ability to find and communicate location is made easy with the use of handheld GPS and other mobile devices such as smartphones. We can also use locally familiar physical references such as landmarks or street signs. But what if the incident has leveled street signs, buildings, and altered the landscape, effectively removing once reliable reference points? What if, as can often be the case in a disaster, electronic communications are unavailable? What happens when an incident affects multiple jurisdictions that use different grid or coordinate reference systems? The U.S. National Grid Reference System can be used consistently and reliably during steady-state and disaster conditions in any jurisdiction. After this video, you will understand the importance of common location language, how this system can be used for planning and operations, and how to communicate USNG point and area references. Module 1. In this module, we will cover the importance of common location languages and grid references. Using a common location language promotes greater operational coordination across communities and disciplines, operations teams in the field, and command staff. The USNG can be applied across mission areas and critical tasks. Additionally, the USNG supports mutual aid planning by providing a common, effective, and accurate grid reference that works across political boundaries. It is also scalable and flexible enough to deliver actionable situational awareness. Past incidents have illustrated the need for a common reference system or common location language like the USNG to improve operational coordination. For instance, in response to Hurricane Katrina, agencies did not always use a common, consistent method to communicate location information or situational awareness, resulting in confusion during search and rescue operations. Hurricane Katrina also exposed the importance of land navigation and map reading skills for field and command staffs alike. Because of the way the storm physically altered the landscape, responders needed a way to describe areas of operation and find specific locations without typical navigation cues such as street signs or even landmarks. Impacts from the storm also degraded solutions like the GPS technology. In fact, after-action reports in nearly every major incident since Hurricane Andrew in 1992 have indicated the need for a common grid reference system. The U.S. National Grid is an effective tool for clearly communicating where an incident has occurred and where help is needed, provided everyone understands and uses a common grid reference system. In addition to lessons learned from past events and incidents, several policy documents and standards have recognized the importance of using a common location language as well. The USNG is a FEMA strategic priority. According to FEMA, the USNG will be used as the standard reference system for its operations, is a reference system that whole community partners are encouraged to adopt, should be part of standard FEMA operations maps, will improve effectiveness and streamline operations. USNG is further supported across federal agencies. A directive from the Chairman of the Joint Chiefs of Staff noted that the USNG will be used to support Homeland Security and Homeland Defense operations, and is operationally equivalent and interoperable with the Military Grid Reference System. The Catastrophic Incident Search and Rescue Addendum to the National Search and Rescue Plan states that the USNG is the primary system for land SAR responders, can be extended for use as a worldwide grid system, and can be easily plotted on U.S. topographic maps with a simple read-write, then-up method, and it minimizes confusion and provides guidance to search and rescue responders. Finally, the USNG is the recognized national standard for land-based location reference set by the Federal Geographic Data Committee, or the FGDC. According to the FGDC, the USNG is an easy-to-use and easy-to-understand interoperable reference system, is easy to communicate, allows reliable transferability of location, and is critical to life-saving operations in a disaster. As you can see from these examples, the USNG is referenced in many interagency documents and guidance and receives broad support as a common grid reference standard. Progress can be seen from recent incidents in which the USNG has been successfully implemented. For instance, in the aftermath of tornadoes in Joplin, Missouri and Tuscaloosa, Alabama, the USNG was used to support estimating the amount and type of debris and to plan for debris management activities. In this module, we learned about the importance of common location language, lessons learned from past disasters, policy guidance for implementing the U.S. National Grid, and examples of progress made during previous incidents. See if you could correctly answer the following questions that summarize the key points highlighted in Module 1. Question number 1. The U.S. National Grid supports an array of missions and critical tasks needed during disaster operations. Which of the following about the USNG are true? A. Interoperable with other systems such as the Military Grid Reference System, also known as the MGRS. B. Can be implemented as a land navigation and search and rescue tool. C. Can support debris removal and management. And D. All of the above. Please take a moment to pause the video while you consider your answer. When you're ready, continue the video to see the correct choice. The correct answer is D, all of the above. This module illustrated the versatility of this location reference system. The U.S. National Grid is most often associated with navigation and search and rescue operations. While the USNG easily supports these activities, it is important to remember that it can also support operations that extend far beyond point reference and navigation. Question number 2. According to the FGDC, which of the following is not a characteristic of the U.S. National Grid? A. It is easy to use and understand. B. It is critical for life-saving operations. C. It can replace survey-grade systems used to identify precise locations on the ground. D. It makes it easier to reliably transfer location information. Please take a moment to pause the video while you consider your answer. When you're ready, continue the video to see the correct choice. The correct answer is C. While the U.S. National Grid is not the standard for, nor does it replace survey-grade coordinate systems, the flexibility and interoperability it provides makes it much more useful in a disaster setting. Also, as we'll see in later modules, the USNG allows for accuracy better than 1 meter locating and navigating to a point in the field. This level of accuracy is more than enough in disaster response situations. This completes Module 1. In the next module, we will cover USNG basics before moving on to more specific information later in this video. We will now turn our attention to understanding the U.S. National Grid and how to use it in an operational environment. Module 2, The U.S. National Grid is both an area and point reference system that offers ways to organize and communicate information that supports establishing a common operational picture and consistent situational awareness from strategic to tactical levels. Using a grid reference system as flexible as the USNG facilitates actionable planning and decision-making that is easily scaled across an area of operation or multiple areas of operation using a standard reference system. After completing this module, you will understand how to read and interpret USNG coordinates, describe or identify areas of interest, and how to apply a common grid reference in an operational setting. A USNG coordinate is made up of three primary components, and any USNG coordinate can be identified on a map by reading right, then up. These basic components of a USNG coordinate provide valuable information, including a precise location and potential size of an incident. To illustrate this, let's look at a full USNG coordinate. At first glance, this may look like a large string of numbers and letters, but when we break it down into three primary components, we see that each piece of the coordinate contributes specific information. The leftmost piece is represented by a number and letter combination. This is called the grid zone designation. Grid zone designations might not always appear as part of a USNG coordinate in an operational setting. If operations are all conducted within the same grid zone designation, it may be stated once for context and then dropped in subsequent communications to avoid repetition. However, if an affected area crosses grid zone designation boundaries, this piece of the coordinate would likely be included to avoid confusion. The next component, represented by two letters, identifies a specific 100,000 meter or 62-mile grid square that falls within the specified grid zone designation already identified. Again, depending on the specific operation, you may or may not use this part of the coordinate when communicating information. The next two components are grid coordinate pairs. The length of coordinate pairs represents the degree of precision from 10,000 meters, or 6.2 miles, down to 1 meter, or about the size of a parking space. Note that this portion of the coordinate is always presented as a pair. The first set of numbers are called eastings, which are found on a map by reading right to the specified number. The next set of numbers are called northings, which are found on a map by reading up to the specified number. Together, these numbers indicate how far east and north to go on the map to find a specified area or location. In Module 3, we will discuss the correct place to start on the map when reading right, then up. The number of digits in the easting and northing pair specifies the precision of the location. For instance, a 4-digit coordinate pair can identify a 1,000 square meter, or about 1/2 square mile, area on the map. A 10-digit coordinate pair that consists of 5-digit easting and a 5-digit northing can be used to locate an area on the map with 1 meter precision, about the size of a parking space. A very powerful USNG feature that enables quick, actionable situational awareness is that grid squares can always be subdivided into 10 smaller sections vertically and horizontally to form grid squares of smaller areas. Grid squares of different sizes nest within one another geographically. This means that within any USNG grid, you can fit 100 smaller grids to represent the next grid level. Therefore, one smaller grid square equals 1% of the next larger grid square's total area, like a 1,000-meter grid square within a 10,000-meter grid square. USNG coordinates are structured so that the length of the coordinate pair indicates the level of precision available to determine location in the form of different-sized grid squares. Decision makers can use this to their advantage. For instance, suppose debris removal has to be performed within a 10,000-meter USNG grid square. By subdividing the grid square into 100 smaller squares at 1,000 meters each, it is easy to track progress. Each time a 1,000-meter grid square is cleared of debris, simply mark it on the map. To know how much of an area of operation within a 10,000-meter grid square has been cleared, count the completed 1,000-meter grid squares to get the percent of total area cleared. 25 1,000-meter grids equals 25% of the total area. The largest areas within the USNG are called grid zone designations. These GZDs are actually derived from another grid-based coordinate system called the Universal Transverse Mercator, or UTM system. Within each of these grid zone designations lies a series of grids that can be subdivided from strategic to tactical levels. These grid zone designations represent the first primary component of a series of letters and numbers that make up a full USNG coordinate address. Within each grid zone designation are equal area grid squares that extend over regional areas. Each of these grid squares measures 100,000 meters on each side. Nested within a 100,000-meter grid square, we see a series of smaller squares, each measuring 10,000 meters per side, or about 6.2 miles. These two levels support most executive and strategic operations. 10,000-meter grid squares can be divided further using the same principles. 10,000-meter grid squares are well suited to strategic or operational missions. From these, we can drill down to 1,000-meter, 100-meter, down to 1-meter precision. As you can see, the USNG can be scaled to manage complex incidents across many levels of operation and jurisdictions. Using the USNG as an area reference system, it is possible to identify areas of interest or operations and communicate situational awareness using a consistent framework. Often, areas of operation are referenced using place names like cities or counties. While providing general awareness of location, these references may not by themselves provide an accurate sense of the scope of the incident when only part of the community is affected or when multiple jurisdictions are involved. The USNG provides a scalable and common language that can be used to communicate area or point references across jurisdictional boundaries. This is especially important in large-scale complex disasters with multiple areas of operations that need to be coordinated and when mutual aid is needed. It allows operators and command staff alike from different counties or states to communicate efficiently and effectively using common language. Using the USNG as an area and point reference system allows all mission areas to focus efforts in a manageable way that fosters actionable situational awareness. The flexibility offered by the USNG allows operators to scale to the desired area quickly and easily. The USNG can be used as an area and point reference system to support operations related to searching for and communicating location of all manner of threats or hazards, including improvised nuclear devices or vehicle-borne improvised explosive devices. Areas of interest and assigning areas of responsibility can be uniformly described and monitored, even in unfamiliar territory. As a point reference, 100-meter coordinates, or smaller, can be used to communicate specific location of devices. From a mitigation perspective, planning or just-in-time actions, the USNG can be used to uniformly identify locations of flood control structures, shut-off valves, pre-identified boom sites, and the location of pre-positioned assets that may be needed to reduce consequences from an incident like flooding or hazardous material spills. Additionally, the USNG can be used as both an area and point reference to support missing child operations. Areas of interest, where the child was last seen or is likely to be, can be described using one or more 10,000-meter grid squares, for example. Areas of responsibility can be assigned using one or more 1,000-meter grid squares. Once located, the missing child's position can be communicated to within 1 meter, or about the size of a parking space. The USNG can be used as an area and point reference system to support planning for, conducting, and monitoring debris management operations. This includes activities like remote sensing to determine likely quantities and types of debris, or sighting and communicating location of debris staging areas. Additionally, the USNG can be used as a point reference to communicate disaster recovery centers, joint field offices, or other locations to personnel that need to report to duty and/or set up these survivor assistance centers. Implementing the USNG for communicating situational awareness and location requires the ability to understand how to read and communicate USNG point and area references. This will be the focus of the next two modules, but before moving on, let's summarize what we've covered here. In this module, we've learned about the basics of the U.S. National Grid, how it is structured as both an area and point reference system, and how it can be applied to any mission area and emergency management operation. To apply some of this knowledge, please complete the following short exercises. We know that a USNG coordinate is comprised of three primary components, and the placement of each in a full USNG coordinate provides unique location information. Please take a moment to complete the exercise by matching the items on the left with the appropriate description from the right. Pause the video while you consider your answers. When you're ready, continue the video to see the correct choices. The correct answers illustrate a complete USNG coordinate down to the 10,000 meter grid square level. Now take a look at this map with USNG grid information. Although the map shows an area at the 10,000 meter grid level, we can obtain additional information about this area of interest from the information provided at the bottom. This is a zoomed-in section of the bottom of the same map. What is the grid zone designation and the 100,000 meter grid ID for this map? Pause the video while you consider your answers. When you're ready, continue the video to see the correct choices. Properly notated USNG grid maps should always have additional location information documented. In this case, we can see the grid zone designation and the 100,000 meter grid ID are clearly marked in the map legend. This information is especially useful when, as noted earlier, the GZD information may not be repeated in an operational setting. Knowing where to find this information when it's needed can save valuable time in a response scenario. This completes Module 2. In the next module, we will cover implementing USNG as an area reference system. In Module 3, we will focus on using the USNG coordinates as an area reference system. As noted before, the USNG is scalable. For the purposes of this video, we will be working at the 100,000 meter grid level and below. Specifically, we will be working within 100,000 meter grid square EG, as indicated on the screen. 100,000 meter grid squares are roughly 62 miles square. Information provided at the 100,000 meter grid level may be most relevant for regional executive situational awareness. It is easy to convey broad areas of interest or operations using these regional grid squares. Drilling down into our 100,000 meter grid, we can use the USNG to identify one or more 10,000 meter grid squares, which are approximately 6.2 miles square, as an area reference for strategic or tactical applications. So within our 100,000 meter EG grid square, we may wish to get the reference for this 10,000 meter area highlighted on the map. To get the area reference information for this 10,000 meter grid square, we use the numbers along the bottom of the map to read right, and the numbers along the side to read up until we come to the bottom left corner of the 10,000 meter grid square. For the reference identified in this manner, the 6 and 8 represent the easting, obtained from reading right, and northing, obtained from reading up for the 10,000 meter grid square. The area of interest or operation can now be identified as 10S EG 6 8. Drilling deeper into this area of interest, we can identify 1,000 meter grid squares, which are about 1/2 mile square, or 0.62 miles to be more precise, and well suited for tactical operations. At this level, we again read right, then up, to find the bottom left corner of a specific grid square. Using the numbers for the 1,000 meter grid gives us a 4-digit area reference. The coordinate pair 6687 represents the easting, obtained from reading right to 66, and northing obtained from reading up to 8-7. Adding these digits to the full USNG coordinate shows how you can at once get tactical level location information while still understanding the broader area of interest. From the 1,000-meter grid level, we can drill even deeper to find specific point locations for people or things with precision from 100 meters, about the size of a football field, down to 1 meter, about the size of a parking space. We will examine this process in detail in the next module, but let's review what we've covered in this module before moving on. Take a moment to answer the following questions about area references with the U.S. National Grid. Look at this map, which shows a facility location with a circular buffer around it, indicating an evacuation zone. The map is overlaid with 1,000-meter USNG grid squares. Using the information provided in this map, how far is the evacuation zone boundary from the facility? Keep in mind that 1,000 meters roughly equates to about a half a mile. The correct answer is about 2.5 miles or 5,000 meters. Knowing that the U.S. National Grid is displaying 1,000-meter grid squares, simply counting the number of grid squares from the facility to the evacuation zone boundary will allow you to approximate the distance. This illustrates how the USNG can be used to effectively and quickly determine distances even without technology. Using the known distances of USNG grid squares is not only good for verifying the distance between features already present on the map, but also for creating features on the fly. For instance, suppose changing conditions in an incident demanded that in addition to the buffer already shown on the map, a 1-mile buffer was also needed. We can approximate a 1-mile distance from the facility as about 1,500 meters or 1.5 grid squares on this map. Marking the map about 1.5 grid squares from the facility, we can estimate the radius of the buffer. We can then draw the buffer through the markings on the map to get our new 1-mile boundary. Another use case that illustrates the power of area references comes from pairing USNG grid squares with other information, such as demographics or critical infrastructure. Producing a map with contextual information associated with a particular place that also contains USNG grid squares communicates actionable information right from the start. Just by looking at this type of map, planners, operations staff, and command staff immediately know something about an affected area when they are able to see relevant information paired with the USNG grid squares that reference an incident. This completes Module 3. In the next and final module of this video, we will cover implementing the USNG as a point reference system. In Module 3, we examined USNG area references down to the 1,000-meter grid square level. The full USNG coordinate for a grid square at this level might read something like this. Remember, USNG coordinates are structured to provide rich information and location at a glance. Just by looking at this coordinate, we know that it references an area about 1/2 mile by 1/2 mile or 1,000 meters square simply because the grid coordinates section contains 4 digits. A grid zone designation references a broad geographic area and when combined with all primary components of a USNG coordinate, provides a worldwide unique address. In the next section, the 100,000-meter grid square letters identify a regional area of approximately 62 miles square. Finally, coordinate pairs provide eastings and northings at the 10,000-meter, 1,000-meter, and smaller grid square levels. Using the numbers along the bottom and up the side of the map with the USNG grid, it is possible to find point references within any grid square with specific degrees of precision. For example, let's look at a map with 1,000-meter grid squares. The coordinate for the highlighted grid square is as follows. Grid zone designation 10S, 100,000-meter grid square EG, 10,000-meter grid square 68, and 1,000-meter grid square 6687. Using our knowledge of how USNG grid squares are constructed, we can derive a point location within this 1,000-meter grid square. With the help of an instrument called a Romer scale, we can precisely locate a point within a 1,000-meter grid square. We are not going to train on the use of a Romer scale in this video, but we can use other means to accurately estimate point references within a given grid square. Because we know that each grid square can be divided into 10 equal rows and columns, we can estimate distances. Also, if the map you're working with has tick marks on the borders, they can be helpful for providing more precise measurements using a straight edge or similar aid. For example, say field teams had to relay USNG coordinate information back to command staff about the location of a group of severely damaged homes located at X on this map. From our knowledge of the USNG, we know that the 1,000-meter grid square that contains the X is 6687. To find the point reference of the X, we simply find the next digit in the easting and northing of the USNG coordinate pair. Because of the way USNG is constructed, a point location within a 1,000-meter grid square will have accuracy of about 100 meters, roughly the size of a football field. This is known as a six-figure point reference because it uses a coordinate pair of 3 digits each for the easting and the northing. From the bottom left corner of the grid square that contains the X, we read right to find the easting and read up to find the northing to get the next digit in the USNG coordinate. In this case, we can see that the next digit beyond the 1,000-meter grid square coordinates is a 4 on the easting and about 4/10 to the right of the 1,000-meter grid square. Similarly, the next digit is about 3 on the northing, or 3/10 north of the bottom of the 1,000-meter grid square. This leaves a final 6-digit point-level grid coordinate pair of 664873. Using the same techniques, we could even get down to a 10-meter level to find a specific house within this grid zone if the situation called for that level of precision. Let's try an example to illustrate how to find a point location with the USNG. Take a look at the following map that illustrates 1,000-meter grid squares. This map contains the following USNG location information. The grid zone designation is 17S. The 100,000-meter grid is QV. Using this information and any other information provided on this map, what is the 6-digit grid coordinate pair for the location of the X? Please pause the video while you work out your answer. The correct answer is the coordinate pair 108625. The first 3 digits representing the easting, found by reading right. The next 3 digits is the northing, found by reading up. We see that the X is in the 1,000-meter grid square 1062. To find the 100-meter point location, we simply read right, then up, within this 1,000-meter grid square to 8 and 5. This concludes the 4-part video on the U.S. national grid. Through this video, you can see why the USNG is so important, how it can be applied to incident operations, and how to better understand its structure and implementation. For more information on the USNG, please visit the following website: www.fgdc.gov/USNG/.